Alright, these are the test corrections for the test taken on December 12, 2019. How do you know which version you took? This is capital M, lowercase m, th. That's how I spelled math. That tells the different versions. So look at that, and that'll help you explain which one you have. All capitals, or one capital and the rest lowercase. Okay, so Mr. Ring going over the Math 5, Chapter 1.3 test. This was taken on December 12th, 2019. Question number 1, the graph of y equals x squared is shifted up. So this description of up is a d value, and to the left is a c value. So if I put it in here to my formula, let me just write down formula. So there is no a value, there is no b value, so it's just your function x minus, and if you're going to the left, this is a negative 9, because you have to have a negative for the formula, and the d value is 1, so x plus 9, x plus 1. Remember my silly phrase, add to x, go west or left. Adding to x, go left. So this would be choice C. Question number 2. Identify the end behavior of the polynomial. I'm first going to look at the degree. My degree here is odd. Look at your easiest odd degree, which is x to the first. Start down and you're going to end up. And then my leading coefficient here is positive, which means my arrows will stay. I don't know if you want more details. 1, 2, 3, 4, 5, 6, 7. But anyways, the big idea as your x values go positive, let me just write. I like to just write it out, and then I can just match it up. Remember, the reason why I give you a graph here is on your x values, this is positive numbers, and this is, oh, it's right there, negative numbers. And on the y-axis, going down is negative numbers, and then up here is positive numbers. So, remember in class we kind of drew a box around this? This pink box is always the same. As you go positive in phase, that's going towards the right, and as you go negative in phase. So you have to test it as you go towards the right. What happens to my graph? It's going up. Up is positive infinity. And then as you go towards the left, the graph goes down. Down is negative on the y-axis, or f of x. And so then I'm looking for one that matches this. They kind of mixed up the order, so pay attention to that. So positive, positive, negative, negative. Positive, positive, negative, negative. That would be this one right there. C would be my answer. Question number 3. Which function could this graph represent? Remember, look at your easiest ones. Easy. You have an odd, and you have an even. What are they? X to the first, x to the second. That's what your graph looks like, right? So both arrows are pointing in the same direction, so I know it's going to be an even and not an odd. So evens, that means it's not these two. And then because it flips upside down, this is, you would have to put a negative. So that's a negative leading coefficient. We don't have that. Now I'm asked about extrema. So let's go here. Extremas, in this case, is a 1, 2, 3. We have 3 extrema there, and it is an even, so my answer is going to be D is the correct answer. Okay, question number 4. Determine algebraically whether the function is even, odd, or neither. So this question is the star question. And you're going to substitute negative x for every x value. And then you're going to observe their outputs. Okay, so let's do that. Every x value, I'm putting negative x. I have PEMDAS, order of operations, to help me. So I'm going to write that 3 times. So negative times negative times negative is negative. So I get negative 4x to the third here. Positive, negative. So negative x squared plus 7. So does that look like the original? We would say it does not look like the original. So that would be even. So it's not that one. Odd is if it's the opposite of the original. So you can factor a negative 1. Negative 1 times something equals 4x to the third. So this would be 4x to the third. Positive x squared. And this would be minus 7, right? So in here, is that the original? No. Not the opposite of the original. Therefore, it is neither. Answer is C. Question number 5. With multiple choice, which polynomial function r of x or t of x has a lesser degree? So let's take a look at it. I'm going to try to figure out what kind this is so you can graph it. Negative 2, 15, negative 1, 6, 0, 1, 1, 0, and then right 2, up 3. So I'm not sure. It could be absolute value, but we can double check by our common difference. So let's do that. This would be minus 9, minus 5, minus 1, plus 3. If the blues were the same, then it would be linear, so it's not linear. So let's test now this one. Negative 9 to negative 5 would be plus 4. Negative 9 plus 4 gives me negative 5. Plus 4 and plus 4. So this means it is a second common difference, which means it is a quadratic. And if it's a quadratic, it means it's x to the second. So my degree here is 2. Let's test the other side. Now, you could distribute all the way through. 3 times this would be 3. X times x, we add the same base. 3 plus 2 is 5. And then 3x cubed. My highest degree there is a 5. So I have 5 and a 2. Therefore, the highest degree in this problem is this part over here. And that would be t of x. So 5 questions times 2 gives you 10 multiple choice. Let's go to the back side. Alright, hopefully these questions are familiar because I just took them from your last quiz. Sketch a set of functions whose product builds a cubic function or a polynomial function with a given characteristic. So set means many, not one, many. So I have a degree 3. So So again, this is odd. Looks like x to the first, starts down, ends up, and it has one x-intercept. Now, when it says a degree 3, we have this on our formula sheet. The fundamental theorem of algebra states that the degree is equal to the real zeros plus the imaginary zeros. So this x-intercept means you have 1 here. And then this one, let's do a different color. This means you have, let's do a different color now. Imaginary means 2. It means that your degree is a 3. Remember your hint that imaginary zeros, they come in pairs. So if I draw this pink one, that means it must be a linear, and it has to go through, that's my 1x intercept. So my 1x intercept is right there. Now, to draw two imaginaries, that would have to be a quadratic, and it must be, cannot touch the x-axis. Okay, that's why it's called imaginary. Question number 7. Period 2, I think, what was the name of one of my children? Brooklyn, Hezekiah, Hadley, Eloise, and Autumn. Third period, so what job did I have in high school? That was Jamba Juice and the library. And fourth period was what is one thing that I liked from the beginning of the year video. Coke, Coca-Cola, Michael Jordan, Boba, and Pomerias. Question number 8. Sketch the basic shape of each function on the set of axes given the number of zeros of the function. If not possible, explain. So you have a quartic function. Quartic means you have a degree of 4, so like something like x to the 4th power. And then it says you have exactly 3 zeros. Now here, I'm going to underline it, different colors, put them at random places. So 3 different dots. And then it says that our a value is greater than 0. So that means positive. Let's write that, positive. So the easiest even we know is x to the 2nd, and it is a smiley face. So that basically means that my graph's going to look something like that. Now, some other behaviors you should know is that the turning points or extremas, the most number of extrema or turning points is the degree minus 1. Let's write that down. Maximum and minimum is the degree minus 1. So if this is a 4th degree, what does that mean? We should have 3 bumps. We should have a total of, at most, a total of 3 maximums and minimums together. So let's go ahead and sketch this. Use my pencil just in case I make a mistake. So that's what we called in class. There's a shoot through. That's 1 0. There's 2 and 3. This one counts as 2 because there's a bounce. So 1, 1, 2. 1 plus 1 is 2. 2 plus 2 is 4. So There's 1 extrema, 2 extrema, and 3 extrema. That's what our graph looks like. Question number 9. The graph of the basic cubic function v of x equals x cubed is shown. So I know this is x cubed. Suppose that w of x is the function of v, but you have x plus 3. Use reference points and symmetry to complete the table of values for w of x. This problem here is referencing transformations. And notice the number 3, and I compare it to my transformation. So notice that the 3 is in the inside of these parentheses, and it's to the right of the x value, so it is a c value. So my c value is negative 3. C of negative 3 means that you're going to the left. So we ask these questions, where is it? Inside or outside? It's inside. It's a c value. Does it affect the x or the y? So I have this rule here, and essentially what you do with your c value, you're going to add the c value. So if our c value is negative 3, you're just adding it to a negative 3, or x minus 3. So all my y coordinates are going to be the same, right? Y it's the same. And what I'm going to do with the x values is do 0 plus negative 3, negative, which is a negative 3. 1 plus negative 3, or 1 minus 3 is negative 2. And then 2 plus negative 3 is negative 1. So here are my new coordinates. Let's go ahead and graph those on the next part. See how that relates to each other. Let's try to make a visual. This is the original function in green. 0, 0, 1, 1, right 2, up 8. And because x to the third is a odd symmetry, graphically, symmetry, that means that it's rotated 180 degrees about the origin. What does that mean? So this would be 90, and this would be 180 degrees. So let me show you symmetry to get the other 2 points here. Instead of going right 1, up 1, you would go left 1, down 1. Instead of going right 2, up 8, you're going to go left 2, down 8. So here in the green there, you have v of x. Try to make those points very clear. And then now if I take my new one, w of x, let's graph those. Negative 3, 0. Negative 2, 1. Negative 1, 8. And if you notice a pattern here, the c equals negative 3 is shifting everything to the left 3 units. 1, 2, 3. 1, 2, 3. 1, 2, 3. You do the next one. 1, 2, 3. 1, 2, 3. So essentially, if you think about it, you can draw a new origin right there. That's how I get my points. See it? Right 1, up 1. Right 2, up 8. left 1, down 1, left 2, down 8. So that's question number 9. Total of 4 points for that problem, each 4 points. Question number 10. Same question from your quiz. Write 2 different cubic functions as a product of functions. Product just basically means don't multiply. See if our students learned their lesson, watching the previous quiz, making the corrections, making sure if it's correct or if it's wrong, writing a sentence and explaining. And that's what helps you realize a problem like this. So, first thing you're going to need is intercept or factored form. What is that? You have these binomials. And notice how in the formula I have this minus sign. Let's make that obvious, minus sign. And basically what you're doing is multiplicity of 2, or think about it, if you order some shoes online, this means you have a quantity, twice of these. So you have 2 negative 4s. And what you're doing is you're putting the negative 4 here. Right? You kind of do it twice. Why is that the case? If you set this equal to 0, you can add 4, and you get x plus 4 equals 0. So where does this binomial come from? You're setting it equal to 0. So this is negative 4, negative 4, and you're left with a 2. Let's just clean that up. X plus 4, x plus 4, x minus 2. And you have 2 of those. So that doesn't count. This is the same thing. Whoops. These are the same things, right? 1, 2, 2 of those right there. So this would be one of your equations. This would count as 1. And we talked about how you can just double. Double everything in your equation. So instead of 1x, you have 2x. Instead of 4, you have 8. And then 2x minus 4. So this would be acceptable. And the reason why these are exactly the same, I'll prove that to you if you graph it, they're actually the same. It's just you put in a greater value. I think I did this on your last quiz, same thing. This is the first one, so we'll do x plus 4 quantity squared, x minus 2, 2x plus 8, that one is squared, 2x minus 4. And the whole point is that it goes through the same exact points, so you're going to have a bounce right here, and then a shoot through. So there's our bounce, and there's our shoot through. And here comes the second graph. A little bit skinnier, but the same idea. Bounce there and shoot through. That's the goal. That's the goal. So these are the corrections for, again, the version that has MATH.